Hello, everyone, and welcome to today's SANS webcast, Critical Defense Required to Defend Your IoT and ICS-OT Environments from Modern Threat Actors, sponsored by Microsoft. My name is Carol, author of SANS, and I will be moderating today's webcast. Today's featured speakers are Ariel Saghiv, Senior Program Manager at Microsoft, and Dean Parsons, SANS Certified Instructor. If during the webcast you have any questions for our presenters, please enter them into the Q&A window at any time. Please note that this webcast is being recorded, and a copy of the slides and recording of this webcast will be available for viewing later today and can be found on the SANS registration page. And with that, I'd like to hand the webcast over to our presenters.
Excellent. Thank you so much, Carol. Fantastic to see everybody here today. And also, as Carol mentioned, we definitely want your questions. So drop those in the Q&A anytime throughout, and we'll answer those at the end in a specific Q&A section. But keep those coming as we pivot through. So as Carol mentioned, I'm joined today with Ariel, and today's topic is about critical defense required to defend IoT and OT environments from modern threats, right? The stuff that we're seeing as recent as things like pipe dream. So I'll do a quick introduction on myself. I'll pass it over to Ariel in a moment. But again, my name is Dean Parsons. I'm a certified SANS instructor. I teach ICS 515, Incident Response, Visibility, and Detection for Control Systems, OT and ICS, the co-author and the instructor for ICS 418 as well, which is ICS Security Essentials for Managers. I won't bore you, so within 10 seconds or less, my experience ranges about 21 years, the first 10 years of my career in IT, and the last 10 to 11 in ICS and OT specifically. So now I'd like to say that I carry a green lightsaber. My experience ranges from the electric sector, from power generation, transmission, distribution, but also oil and gas facilities, marine terminals, and assessments in various different sectors in OT and IoT as well. So with that, I'll pass it over to Ariel.
Hi, everyone. Great to have you here this Thursday morning or afternoon, wherever you are. I'm Ariel Saghiv, a security engineer and the lead OT product manager within Microsoft Defender for IoT. I don't have a lightsaber. I use the force. Well, I try to at least. And the force of good. And my goal is to enable blue team defenders wherever they are and whichever system you are protecting. Because at the end of the day, that's what matters, and that's what brings safety, production, and a good feeling in the heart. So, what are we going to talk about today? What do we mean by critical defense, and why are these assets critical? First of all, the defender's challenge. Today, defending these networks today, these business critical networks, operational networks, is not easy. It's even complicated. It requires teams and cannot be done by a single individual, actually. And I believe, I believe that at the end of the day, turning on the light, creating visibility into the networks, into behavior of devices, into activities, and into the way networks and processes should behave or shouldn't behave. That's our force. That's our force of good. That's our light, the way that we can take it forward and move into a world where our SecOps is effective. And how do we run through these security operations? How do we deal with these daily events, some of them minor and unimportant, some of them super important? How do we deal with them within the unified SOC, where we want to have all the great minds at the end of the day working together in order to reach effective security for your organization? And of course, we welcome your questions and we'll take them right at the end of the session. So the business critical systems are everywhere. Operational technology, IoT devices. It starts off with, it can range from traffic lights, oil and gas, refineries, energy production, and sometimes, and even the air conditioning air conditioning and ventilation in every modern building. These devices are around us. They're in the invisible space sometimes. We don't see them, we don't pay attention to them, but they're there. The ventilation keeps working, the lifts keep running, the traffic lights serve us daily. It starts off at the production facility, at the areas where we see it more, where there is the safety impact, where we see the OT devices, the engineering workstations, the HMIs, the PLCs, and so on, but it's also the devices around them. It could be the network devices, it's the printers, it's the PCs, the IT within the OT network. These are also part of the environment, and they cannot be ignored. And it goes on into the rest of the organization, from the different critical production networks, but it goes into the back office and logistics operations, accounting, our public-facing infrastructure. And today, with digital transformation, Industry 4.0, this just keeps growing and growing. And we see the number of smart devices, automated devices, unmanaged systems growing and growing by leaps and bounds. And there will probably be more devices than human beings, actually. And we need to manage this. And this is everywhere in our organizations today.
I totally agree, Ariel, on this. Totally agree that there will be probably more devices than us, and more vulnerabilities come with that. I mean, there's clear benefits though, because we do have these automated devices clearly helping out with safety aspects, automation aspects, efficiency aspects as well. And so, I mean, what I would suggest is not to say, no, we don't want the technology, no to 4.0, right? It's how do we embrace it and secure it at the same time so it supports safety, right? And it's the kind of old adage of how do we get ahead of it, right? In control systems, how do we bake security in as projects and new technologies come in? I think you're nailed it. and I laugh because you're right. I think we will have more devices than people on planet Earth.
And the thing is that security should not become, you don't stop production, you don't make problems, but you enable it to be better. You
Right.
create the ability to see that things are working correctly. And these devices are there helping us. It's a good thing, but it needs to be taken in responsibly by the organization. And going forward, and if we take, of course, the some of the recent events that we've been witnessing around attacks to different industries and in different geographies, in different parts of the world, I think that the thin line that we can run through the different events, and then we can discuss, and they've been discussed endlessly in many sessions and many different analyses. But at the end of the day, these events represent a state that we don't want to be in. We don't want to be, and when I see this kind of events, and I say to myself, wow, if I was that operator sitting in front of the desk and it was my responsibility to stop that attack, what would I do? What would be my tools? How could I help my organization? And everyone would be looking at me. And so when we look at these events, I think the first thing that we can see that's common, and it goes back to the concept of visibility. If you have visibility in time before this happens, if you have the ability to understand that something is changing, then you can take action in time before it becomes, headline news or an event that's published all over. And I think, and behind each of these events were security engineers that used the tools, attempted to introduce and implement the different security tools to avoid these types of situations. And I think that's the goal. The goal is early detection. The goal is understanding, and the goal is also breaking down the silos, working together in the organization. And I think going forward, things like pipe dream, I don't know if everyone, this is quite a recent malware that was released, but this is a kind of, if we delve into pipe dream a little bit. So pipe dream is a malware which uses native protocols to perform malicious actions on OT devices, on these types of systems. And to detect these kinds of events, it's not enough. It's not only detecting a malicious signature, but it seems like it's living off the land in a way. It's running within your system. Dean,
yeah, absolutely, Ariel. I'll jump in there because I think this slide really emphasizes what we've seen over the last decade, where we kind of came from, what we anticipated, and kind of where we are. To your point, two things I want to mention, and brilliantly you mentioned things like pipe dream, which I'll dive into in a second, but also what would an operator do if they stumbled across some actions from these events? So I'll take Colonial Pipeline, for example, or even the Florida water treatment facility that was compromised. Now, earlier, Ariel, you mentioned a human machine interface or HMI critical asset in any OT environment, which in that case, 2021 was targeted. Now, an engineer noticed that an adversary was on the human machine interface directly connected to the internet with weak security, and then adjusting the human machine interface. In that case, you mentioned living off the land, which is exactly what that adversary did there, and pipe dream is similar. So how do we detect this? Endpoint detection may or may not pick up these things. And so I don't want to take your thunder. I'm sure you're going to talk about visibility later, but things like pipe dream, a scalable ICS specific targeted framework, we're likely going to see that expand upon. Abusing the protocols, which currently it abuses OPC and a number of other different protocols as well, like we've seen with crash override, DMP3, and so on. And it takes advantages of the engineering software on other critical assets, such as the engineering workstation. Many common operating systems or common software engineering software is installed on that critical device, which is taken advantage of. And the thing is Pipe Dream only a couple of weeks now disclosed publicly. We've known that Pipe Dream now can actually execute almost 40% of ICS attacks, the techniques specifically used in control environments, and 83% of the techniques if we look to something like the MITRE ATT&CK framework. So I think we're going to see more of the pipe dream expanding. I think that you're right. I think we need to get visibility to see how these things can be abused because it is living off the land. So love this slide and love that you brought up pipe dream here. And it's something that I think any organization with any OT technology running any engineering devices should be keeping abreast of.
And I think the message here is that, you know, this type of malware is it's automated. I mean,
yeah.
When you think about it, it's going to happen maybe at a time even when your SOC is not even manned, you know, it's at night by a student and so on, and it runs much faster than you are able to. If your time to contain and triage an event is between hours and days, this is long after this has been running rampant on the network.
Right, and the good news is it is detectable if we have visibility and we have trained people looking at the control systems and expecting what's odd in the OT environments. Do you agree?
Totally, and that's the point. That's the early detection. I think that's the best tool as defenders we can take care of. We can prepare, we can train, we can run the tabletop exercises, learn, simulate where things can happen in our network, and treat them before they become incidents or security events. And I think that's the message, and it is possible. I think that's the other message. It's not a theory. It's not something that you would now, you know, it's not a dream. It's not a vision. It's something that's totally possible with today's solutions and today's tools, and it takes you to another level in terms of incident response, and before incident response to preparation and the day-to-day security. And I think as a general summary of the last slide's events, you know, the attackers today are evolving. It's amazing. I saw this in recent studies actually from this year. You know that today there's malware as a service. There's you have business model. There was a leakage from one of the malware groups with the HR department of a malware group. The business there in terms of you know, investment and business models are evolving on the attacking side, on the adversary side, which is amazing. You know, it's bringing in money, sometimes amounts that are as high as your APT groups, which is crazy when you think about it. And these services are available for use, you know, for pay-per-use, basically. And it's not so. The attackers are evolving. We have so many security tools today, and we have more security tools because we have one for the email, one for the firewalls, one for monitoring the network, and so on. And the number of tools is growing. And then, you know, even if it's good, all this goodness can become noise, and we don't want it to become noise. We don't want alerts spilling in or endless logs spilling in without an ability to understand if, you know, to sift out of it the pieces of gold in there. And it becomes impossible
I think you're right. It's that cat and mouse game, right? They do something, we do something, and invariably we will ingest events from a sim, which is converged or not, but we're going to invest or ingest and get these events of interest. How do we determine, I'm looking at your slide here, overwhelming noise out there. How do we determine what's an event and what's actually in kind of an incident we have to respond to? And loaded question, who responds to it in IT or OT? Is it a combination? Like, it's a tough one today. And from our perspective, we're seeing a number of organizations converge those themes, but some organizations are very much against that, but still trying to achieve the full visibility across, I guess, what we call in the community, the ICS cyber kill chain, visibility in both environments. So what's your thoughts on the overwhelming noise that's out there? How do we detect the signal that we need to respond to?
So, wow. So first of all, it's a loaded question. And I think and it takes me back, when you ask me that question, it takes me back into making decisions. How do you make those decisions? And I'm going to go into that in a couple of slides. So I think I'll answer it right over there, because at starting, and I think that's the message, that's my message. And that's what we do at Microsoft. We want to enable defenders with the tools to easily implement, easily deploy these tools in order to reach that unified view, to be able to see, to turn this, to reduce the noise, to sift out the noise and stay with the relevant information for decision making. And that's the goal. And that's where that's the message here. And taking it a bit further, it's the tools that we have today in IT, and I think that's also something that comes up sometimes, and we get those questions. Why do we need specialized tools for OT at all? And that connects also with the question about noise, because IT tools are not tailored for these types of environments. The OT environments are sensitive. The equipment does not even like to be probed, and what's called invasive scanning is not really good for these systems. Sometimes the process is in play. You cannot even use it. They do not allow you to see into the process itself. So things like pipe dream that we've just discussed are not visible, because we are looking to see if the process has changed. We need systems that allow understanding of these automated processes that are running in the system. So the IT tools, and of course, firewalls control your perimeter, but you open a port and any kind of data can go through that port. So it's not enough. It doesn't provide high return on investment for using these tools, especially within the OT environment. You can use, of course, you should use, of course, the combination, but still it's not enough. And that's the tailoring. Now, the other aspect of this is the compliance aspect, which of course there are different standards. It can be 62443, it can be the MITRE framework, NIST, NERC-CIP, and so on. And having compliance in a way, it doesn't mean you are secured. It means you are compliant. But our goal is not only being compliant, it's also being secured. And what I do like, and what we do recommend, of course, is following the different compliance standards is great, because it's a framework that you can follow, that you can check off, that you can have alignment within the organization, and it puts things clearly. And I think that my only focus point here around identity, and we take NIST, which is very common and very easy to understand. And I think the weight here on the different steps of NIST, I think the weight should be placed on identify. Because once you are able, and that goes back to the visibility, when you don't have visibility, you don't have all the rest. If you're not able to understand what your system is doing when it's working correctly, you cannot protect it, you cannot detect, you cannot respond. And I think that's the key. Now, taking it a bit forward, and this is where we want to be. And I think this is the work and the enablement that is the best to do within your organizations. And the question is, how do you do this in your organization? How do you deal with the inventory or the mapping out your networks, even discovering them, knowing what is on them? And everyone started off with that Excel spreadsheet, and I'm sure you have one, or a picture on the whiteboard.
Yeah. Dude, don't get me started. That could be a whole other web series. I've been there. When I seen this, I'm like, yeah, that's very similar. What I'm noticing here is that you have the right details here, right? The protocols are being used, the firmware of the engineering devices, not just the operating system, which we know 80% roughly of control systems or OT environments are not running traditional operating systems. So the firmware of those control engineering devices critical when you add threat intelligence to it to understand where your vulnerabilities are. I don't want to steal your thunder from this, but looking at the live questions we're getting are fantastic. I do want to address one, and you mentioned this earlier. You mentioned that IT tools are not suitable really for OT and ICS environments. And Don here in the chat, and thanks very much, Don, for your contribution and connecting today. He talks a little bit about like the value of basic anti-malware behavioral anomaly detection versus resilience and response, and maybe tabletopping out a bad day. A couple things I want to just mention on that. For sure, a copy and paste of IT into control systems will break your control systems and will nullify a lot of safety. And essentially, I've seen, unfortunately, organizations have teams go in and do that, paste the IT tools and processes in ICS, and they get kicked out of the environment because something bad happens. And so I agree that to Don's point, they're not the same. Having specific tools are required. And I've always to say what anti-malware endpoint detection tools could be used in ICS. I would say on traditional operating systems, 20% of those devices of the engineering being 80% would be whitelisting antivirus solutions where behavioral anomaly detections may actually break components of the control system, legacy software, and so on. I think from a networking perspective, passive network monitoring, such as intrusion detection systems, are going to be helpful there as well. And what's your thoughts on this one? I know we're good on time for now, but I can see this expanding. But tabletops, from my experience looking at earlier slide that you had on Colonial Pipeline, when that hit the oil and gas environments, we've seen oil and gas facilities take that on as a tabletop. If this were us today, what would happen? How would we roll? Would we depend on IT and the controls there for the control system? Can we continue processing oil and gas refinement and pipeline execution in that environment? So love that you mentioned tabletops, and we're talking about tools here, which is fantastic, and they will enable tabletops, but starting out with a tabletop will really determine what visibility you have or not have, what type of tools and technology you have as well, right? So anyway, back over to you.
I think that first of all, you touched on a point which I love. We call it people, process, and technology.
Yeah.
You can't do with, you can have great people, and without technology, they can't manage. You
Yes.
need the process in place as well. So the tabletops are great for discovering that. And if we go back to that example on Colonial Pipeline, well, they shut it down because they were not sure even of the impact of the malware on the OT operations. The malware hit the enterprise network in a way, but then, and that goes back to visibility, and for the operators and defenders to feel comfortable with the environment that they are defending. If you're in an environment where you say, well, it works, don't touch it until it breaks, when the day happened that there's an issue, you're afraid to even touch it. You don't know what it's going to do. And I think, and that's the benefit of the tabletops. It's taking the people, the technology, and the process, putting them together. I think the simplest tabletop that I can remember, it's the question of recovery. Okay, let's have a practice session of recovering the system. Just recovery. Let's say it was wiped out and we need to recover it now. And it's amazing. The questions start out, where are the backups? You try to restore them, they don't work. You reclone the servers and so on, and it doesn't end. And it's amazing how much value you can get out of even one tabletop exercise in these areas. And the other area here, if you can see on the slide, that Excel spreadsheet, it's usually not up to date. And of course, that it doesn't monitor the real situation. So it would usually represent the system as it was delivered. And if you have great change control in your organization, it would be more up to date. Still, it would not be up to date to today. And that's the first area of visibility. That's building this inventory, building this map, and even visualizing it. I think this is part of my favorite moments of working with customers. It's having, when we see the map for the first time of an environment, You know, that it brings out the wow, because for the first time you see this huge kilometers wide refinery. What is working with what? Which device is talking with which? It's amazing. And you immediately get the question, hey, what's that device? You know, even just the representation in the map clicks it. And then taking it forward, you know, we wanted to, you know, we wanted to say that everything is air-gapped, everything is disconnected. For the last couple of years, when we've been seeing working together, we've been seeing this in environments that they weren't exactly air-gapped. Sometimes all kinds of connections were there. And today we're at the place where we know digital revolution and industry 4.0 and so on take us to the place where everything is connected. It goes up to the cloud, it goes up to our supply chain, it goes out into logistics and so on. These systems are less and less air-gapped, and in some way we need to deal with it. So first of all, it's identifying them, allowing you to segment them. Sometimes it's even running them on separate VLANs. You know, you'd be amazed how much even that basic, you know, hygiene on your network, what kind of magic it does. You know, it's like washing your hands. You put it in separate networks sometimes, and it's a project. Changing these operational networks is definitely not, it doesn't happen overnight. But once you see it and you know that this is happening, you're able to segment. You are able to put them aside. You're able to control it when experts from one system come in and work on it so that they don't touch another system and so on.
I think that you're nailing with segmentation. A lot of assessments that we've done really indicate that, and this is across the entire community or sector, not just one specific ICS or critical infrastructure sector, that I see organizations say, well, we need $1 million to get a technology. That's awesome. You need that people, process, and technology for sure. But it's great to start with a foundation that you can build on, right? That's the architecture and design. It's actually very affordable to do architecture and control systems. It takes time, but you can do it. It's affordable. It doesn't cost potentially this $1 million for a tool. But after it's built, then is the time to look for a technology to automate your detection as well, right? One other thing you mentioned there is really getting that visual, right? We're visual creatures. We want that map on the wall of our entire network during incident response. I have one in my war room, the whole thing in a locked area, all that. But it's very much focused on incident response. How do we now respond? The adversary is here, here, and here. What's the impact to safety and reliability? So great to have the visibility. So the question I have is, there's really a number of ways to get an asset inventory, and digitally to getting that representation. You commonly see organizations either go with an invasive active scan to obtain that, or passive scan as well. I want to get your thoughts on what's better and why, active scanning or invasive active scanning or passive scanning. Because we're concerned about legacy devices still in the ICS, and we know active scanning can have unintended consequences, right? Not always, but it can. It's a risk factor.
I think you're touching on a hot topic. You know, you have different ways to acquire this information. You can integrate it. You can have someone sit on that Excel sheet and update it. You can import configuration files. You can use the go active or passive. I think, and that's, you know, my from an effectiveness viewpoint, I love the passive, and I love the passive for the main reason that it gives you, it surprises you. It gives you the surprise of the devices you didn't expect are there. You know, this is probably building on the years of experience in projects. But you know, you work together. Say, okay, this is our network. These are the IP ranges. These are the systems we have now. When you take it from an active standpoint, you plan your scanning. Of course, you are responsible. So you plan your scanning, you plan the different active scan components, and then you can miss out on components in the network. When you're doing active scanning, you can enrich. You can use active in a smart way. So you can use the active scan to enrich information out of endpoints that are going to help you. But for the first step of visibility, I like to start with the passive, and then it gives you that map, it gives you that information, and then you can start enriching. And there you can add on with the different tools. So it's a combination. That's I think, the end of the day, every tool has its benefits, every approach. but from a point of view of where do we start, how do we introduce visibility. And you know what, sometimes, you have that feeling when you don't have the map and you don't have the visibility. I have a feeling that things are not connected well. I see in the network switch that the CPU is 95%, but you have the feeling you don't have the data. And with these types of tools where you map it out, you have the data. You are able to present. Look, you don't have to explain it. You just show it. And I think that's for me, that helps. That excites me. That helps make a change and turning a system, implementing zero trust and segmentation and all of these big words. But at the end of the day, that's what it's about. It's about even starting with the basic hygiene. And then going forward, you would have, of course, so patching. Okay, so patching in OT, and that goes back to the IT tools in OT. Patching is not always or usually not even possible. Sometimes the systems don't have a patch. Sometimes the vendor is already not in the business, and sometimes it was a system delivered as made. You cannot install any kind of endpoint protection on it. You cannot patch it because it's in operation, and it takes you to schedule a maintenance window 6 months and so on. So these systems are sensitive, and this is the way they should be treated. And then in order to deal with them, there are other approaches. You can use the simulation approach, attack vector detection, and so on, understanding your attack surface and building around it. So sometimes it's not just saying, okay, we have 1,000 devices to patch, but maybe there are ways around. And once you simulate and identify the most important vulnerabilities or the choke points that you can control, it can be your jump host, it can be your firewall configuration, it can be a combination, and then you are able to do 80-20, 90-10. You can deal with the really important things and build around to create that defense, even if this network is sensitive to upgrades, sensitive to changes, and so on. And I think my last point here is and this is the goal. So we want to reach this high velocity SecOps, high velocity OT security operation. And if we look at the manual containment, triage, recovery processes today in organizations, as I mentioned before, malware like Pipedream or Industroyer before it and so on have become so automated and modular that these processes today cannot happen in time. We as humans reaching decisions together, discussing, collaborating, bringing it up to leadership, getting agreement and so on, until you act, the event is all over. And then this is where other machines can help us. Not only the attackers have to evolve, we can evolve as well as defenders. And that's part of harnessing the tools of machine learning, of automation and so on into cleaning up the information. So as a concept, which is something that is today hard to implement directly into OT, but can happen around in this protective cocoon you can build around the OT infrastructure. And then having the people working together, that's the unified SOC, the IT and the OT teams, the experts working, putting their minds together. It's the people, it's the process, and it's the technology working together in unison. And I think that's part of the mindset change. IT has always been in OT. It was there. Maybe you didn't call it IT, but the Windows 7, the Windows Server, the Linux server, and so on, these devices are there. So and the attacks, they come in also from the IT network. The air gap is not not there always as we would expect it. Even and sometimes we discover it, by the way, by the passive monitoring, we discovered that the air gap was not where it was supposed to be. So I think that's the message here. And that's reaching this place of the organization working together and reaching the goal of protecting this enterprise of things, enterprise of business processes, which involve people and automation and machinery and logic and so on working together. And I think if I concentrate it, I sum it down, it's visualize, identify what you have, what you want to protect, and break down the silos in the organization. I think that's today the challenge that defenders have from the top to the bottom of the security team. I think these are the largest challenges that we want to address. And if we take it into a proactive approach, how do we start? Where do we start? What do we do? We typically start with asset discovery. And you know, I challenge our viewers to ask yourself, how do you discover devices today? Do you really know if you have a rogue device? Do you know if an operator brought in a laptop from home and connected it to the network just to watch videos on the night shift? You know, these kinds of things sometimes are not, you know, the advanced APT threats that are targeting your network. It can be the most basic things, that events that happen. So it starts out with this discovery. And ask yourself, how do you do it? Dean, I see you smiling there.
Yeah, I mean, this is hitting home for me. We've responded to incidents and control systems specifically to transient devices like you just mentioned, or a rogue device that comes in and it doesn't intentionally try to bring in malicious activity, but does because someone getting to a dam in a hydro facility is a 6-hour drive. So they have to sleep in a hotel before they get there and travel to get to the location. And they pick up malware somewhere along the way, maybe in a hotel or somewhere else. They walk through your facility, through all of your physical security, right by your firewalls, right by your intrusion detection system for ICS, and plug into a controller at the lowest level of the Purdue, or Purdue 1 or whatever, or 2. So it's hitting home. And the good news is MITRE ATT&CK actually does now have, very recently, put in the quote unquote transient cyber asset identifier, which actually has mitigations. And I believe the ID is T0864, but as an initial attack into the ICS. So when you said that, that's where my laugh came from, out of responding to that stuff to reduce impacts. And we've seen it. It's a practical vector into ICS.
And I think that's what I love about the MITRE framework, that it modules everything down, it flattens it into a structure. You can take a look at and understand. Again, going back to visibility. And that's the visibility, of your risk and of the behavior of monitoring your systems. And that's the visibility we want to gain. So we start with our perimeter, understanding the devices and the activities within, understanding which vulnerabilities we have, and also prioritizing what we need to take care of today, what we need to take care of this month, what we need to take care of this year, and what have we blocked somewhere else in our organization and we can clear out. And then going into continuously monitoring that, because finding out that transient device, that rogue laptop in your organization, you want that to happen and to be alerted about it in time, and not when that operator has already left the facility and you can't even find him, and you have to deal with the repercussions of the event. I think the other area here is also helping for operational efficiency. So once you get that visibility into the activities on your system, sometimes you find things, overloaded switches and routers with too much traffic going into them, or high availability, or disaster recovery processes which don't trigger correctly, don't switch correctly. So this visibility gives you all across benefits. And I think the other side, again, that goes back to the people. You want to be able to see this in one place, and you mentioned this, having the one system, the SIEM, the visibility in the one security control mechanism that allows your team to workflow through the events, to delegate responsibility, to research, to conclude, and to control the different security events coming in one unified solution. So maybe the first step here is identifying what you have, visibility to the devices on your networks, and I think that's the first mindset change. So of course, as we talked about here, the OT devices, the PLCs, the HMIs, and so on, the directly critical OT devices controlling the processes which have direct impact on safety. But around them, remember, we have these invisible systems, the VoIP phones, the printers, the smart coffee machines, the network, but that's reality. The voice assistants, all of these smart devices that are all around us and growing. The laptops, the smartphones, of course, and all the rest. So we want to protect all of them because all of them are part of our environment. We can't ignore them. We can't just look at a subset of the environment when all of these devices are on the network and they are part of our attack surface. And then, so you want to place the right sensors in the right places. You want to monitor your operation and then bring in all the information together. It can be from the Defender for IoT solution that we develop, can be from third parties, of course, but the goal is bringing this information into one place. And the information should be rich, not only IP addresses or MAC addresses, but it should include what these devices are, what they are doing, understanding dissecting the protocols, if you will, all of these mission critical protocols, Modbus, DNP3, CodeSys, and so on, all the different systems that are available today in every type of vertical, zooming in and understanding what these systems are, what they are doing, and taking this information from, we called it noise, from many bits of data, but taking it, piecing it together, building a baseline of a behavior model, what the system should behave like when it's operating correctly, which devices are on this network map, which behavioral attributes can we identify in the system, and then once you put this together, once you piece it together, you are able to identify when there is a change. And then you can go on into assessing risk, into identifying vulnerabilities, and into monitoring your system for a change. Even if the change is, what you'd call a 0 day, something you don't even know how to identify yet, but something has changed in your network. So it could be a maintenance operation which was unreported, or it could be some kind of software doing something on your network which you never expected to happen. The other part of this is continuously researching and connecting to the right threat intelligence that would help you detect these types of behavioral changes on your network. And I think that's the complement. So it's not only mapping out the network and the control, the perimeter, but it's also building in the understanding when you see a process, is it good or is it bad? Is this pattern of activities, if we go to the MITRE framework, which I'll reach to in a moment, and if this pattern of activities belongs to a kill chain, or is this just an event that we need to mitigate and produce some solution to avoid it happening again. So this is the goal, the unified view, the unified inventory, the maps, seeing all the different devices in the one place, starting off with that live Excel spreadsheet. And this is totally attainable. This is easy to implement, easy to use, connect the traffic in, start monitoring. It's 80-20, you get the 80% just by starting to monitor. And then going in deeper. And that's part of the value of the more specific behavioral anomaly, OT-oriented security systems. You are able to understand which components are in your environment. Are they running in a secure state or not? If we go back to the Triton attack, we can learn about the programming key that is 2 kilometers away from the operator, and it's left on the programming state, just for they don't want to go out to find the device, but that's real life. Sometimes it's not even physically viable. Get that dam, as we mentioned, but this is real life. It's all based on real life events, and that's the value of these OT systems. With the idea of going to a place of putting the people, processes, and technology together in the SOC, and I think that's the other area that I'd like to call on defenders to identify. Ask yourself, how do you deal today with these events in the SOC? Are the security engineers, are the IT security engineers helping the OT security engineers? Are they working together with all the possible tools and working within solving problems, understanding the business impact of a system? That you cannot block a port from a safety system that is monitoring a process. You cannot cut out a piece of a manufacturing process and cut it out of the process. So reaching that understanding and implementation of the security and operational teams that are responsible for the operation working together.
You know, Ariel, I think that you mentioned earlier getting the map, that passive map is fantastic. Here's where you talk about the people, process, and technology where, okay, great, you use the technology, you have a map of the network. Awesome, step one, check, you're done there. Moving forward, though, the question is, and it came up live as well, and we've answered it as well, but I want to bring it out here to say, how do you know, or how would we know, or how would you need to know which ICS assets and OT assets are critical? And that definitely, there's a subset for sure that exists in most any ICS or OT environment, and it will vary depending on the sector. But if you focus on getting the network map, identifying the human machine interfaces, the Windows OT devices running engineering software as an HMI, but also the embedded HMIs, also the engineering workstations, those two assets, but also the historian. Critical to find those assets at the get-go. Those are the ones that, one, we know that if they go down, there's going to be possible consequences, lack of view, lack of control or manipulation of the process, safety impacts. But also, here's the great thing. Minor attack or any other threat intelligence that you ingest, we've seen attackers focus on those or towards those critical assets. So starting there with the top 2 or 3 we just mentioned is a great place to start. And how do you do that? You're not going to get that necessarily just from a passive map or active map. And this is where the people side of it comes in. You need to talk with engineering staff. They need to be a critical part of that conversation. Walk into a plant to say, hey, you know, if that device over there goes down, what happens, right? And if you get the response, oh, well, we should exit the building because that's a safety system and that will shut everything down. But if it fails, then we're in a safety problem. So having that conversation for sure is the key part of the technology first, the people, and then the process.
And I'd like to add to your question, you know, I think what's the other part of devices that are important is the invisible ones.
Yeah.
You know how important the protocol converters that you have from serial to Ethernet are?
Yep.
You know,
take one of
the impact they could have on your safety.
You take one of those serial to Ethernet converters out for a safety instrumented system, and not only are you traveling to site, right? You'd have no visibility possibly for your safety at site. So critical devices. Yep.
And I'd like to connect to your answer. So it's not, I don't think that the workbook here for identifying these crown jewels or the most sensitive devices, the truth is that it's personal per each system, per each environment. I think there's no way around it, because at the end of the day, that system, the safety system that's, you know, protecting the safety of the operators on site would be different in every system is built differently. It's its own special snowflake sometimes. So, and that's the hard part. It's adapting and finding out these critical security checkpoints that you want to place on top of these crown jewels, crown assets that you have in your environment. And you know, we can see here this example of an event where in the SIEM, within the SOC, we want to see this happening. We want to see the event with all the information around it. You asked about how do we do this safely, and of course you have all the technicals. You have the VPN, the proxies, the one-way firewalls, whatever. But you know, bringing the information into one place and having it pieced together, so that when you look at an event, you see the IT devices involved. You can see the string of events that happened through and through, and then place and you know, allowing you to also perform the threat. The threat hunting, the incident response, and then going around, seeing what else was affected, where else has this activity been spilling into on our networks, and so on. And that goes back to the people, the process, and the technology. And if we visualize it, how would we want? I mean, that's the vision, that's the dream. And then going back to our audience, you know, how do you do this today? How do you deal with these types of events in your network? How fast can you run through this triage, containment, and recovery process within your organization? Of course, you have in the background, you need to have the information available to run through the process. If you don't have visibility into your systems, you can't even start. But that's where we want to be. We want this process to be the most automated, the most easy easy to implement, and at the end of the day, having the source systems in a way being able to help us with the different rules and workbooks in order to clean up some of the noise and clean up some of the events and so on, and implement a system which prioritizes the real events that you want to deal with. And this goes back to MITRE, which we discussed. I think this is one of the nice things that we are busy with, and we get lots of traction in this area from our users. It's how do you visualize events and how do you use the MITRE framework for blue team defenders. So it's not only looking at the live blue squares shining up, but understanding, being able to find out the patterns and learning as a blue team how to protect your environment, where you should invest, which areas of your own environment are unprotected, and you need to bring in the right tools or bring in the right configuration, blocking a firewall port or changing something on an endpoint that will allow it to be resilient to this type of event. And if we take as an example, the basic, unauthorized changes to an ICS device event, where we would have a programming of a device where these two devices, that this PC programmed a PLC, and we would like to know what happened. Was this device programmed or sent it commands? If it was, especially with the MITRE attack for ICS with the right flavors inside, you're able to model and work together in a team, understanding what is the impact for this on your operation, on your network. Is this device sending restart commands? Is it trying to program the device, and so on? And in this case, this was an unauthorized terminal which accessed an engineering workstation. So we don't want this to happen. We want to be able to visualize it and see easily and understand. Now, in the dream, the workflow in the SOC, it's complicated. There's building a SOC, building a unified SOC operation is complicated. This slide is complicated because real life involves many steps, triaging these events, but I'm showing it here because the tools today, the solutions, the knowledge that has been built up by vendors within Microsoft, with working together with the larger security community. Today, many of these processes can be automated, can be effectively and easily built into your organization. So it's not about performing each of these steps manually. Means that your incident response, once this event happened of unauthorized change, this will take you between hours and days to research what happened. And our goal is basically allowing you to reach a conclusion within minutes of a tier 1 operator overviewing the security system. That's where we want to be. We don't want this to be complex. We don't need to wake up at night, the only operational engineer that knows the system. We want to have the processes as easy to implement, as fast as possible, and focused as possible to be effective for your organization. And I think I'll finish off a bit here with where do we want to be? We want to be at this place of cyber resilience, of taking all the different tools, all the different abilities, all these birds alone are just birds, but together they become something much larger. They become this cloud of birds, and then the predators don't go to attack them because it seems something too large to bother with. And the attackers, the adversaries are evolving, and the defenders also need to evolve. And this is where we invite our users, our customers, and if not yet, you're welcome to try out our tools and help reaching together for your organization cyber resilience, the understanding, the ability to make effective decision making, the ability to have the visibility into your network and the right processes in place to be able to do early detection of any kind of change in your networks, and giving and providing the technical capabilities to all the teams involved in ensuring security in your operation. It's not only the problem of the security team, it's a problem of everyone, of the operational teams, of the security team. Everyone is affected when there is a security event. So first of all, if you don't know about our community program yet, You can use this QR code or use the link. We invite you to join, where we have further more specialized content. And of course, we continue working together with SANS and happy for advancing the security community as a whole and providing security education and tools for increasing the security. At the end of the day, these systems are what our modern life depends on. We love electricity. We love, we love power. We love the internet. We love communications. We love the modern life, and that's part of keeping it safe and keeping it going. And so we are happy to work together with SANS and the community, and we invite you to join the Defender for IoT community. And also, if you're looking for more information, and this presentation will also be available and shared out, we have all the different resources on the product, on different articles and research work that's being done by our teams. And we're looking forward for you to touch base with us and happy to work together.
Excellent, Ariel. Looking at the time here, we're really good on time. We got a few minutes left here for sure. And I think that Don in the live chat is looking for a community link. If we can paste that community link in the chat, I think that'd be fantastic. While we're doing that, I think we have a couple of questions queued up. There's one I definitely want to address before we move on to the last 5 minutes here. And this comes from Asit. And he indicates, managing safety-related incidents triggered by a cyber attack. How do you manage that? How do you actually approach that? And so he indicates he believes that safety and security are inseparable. They go hand in hand. And I completely agree with that. I think that in OT and ICS specifically, it's security supports safety. Safety is king and queen, like it's number one. And so this is why, going back to tools Ariel mentioned, we use detection rather than prevention. I don't want your security team walking into a plant and dropping packets with an intrusion prevention system and having issues as a result. So I love the fact that you have inseparable safety and security in there as well. But I would agree that the safety professionals should absolutely be part of tabletops, be part of the incident response for control systems, for OT. And in fact, they probably already have something. Engineers are used to dealing with emergencies where a cyber attack can now cause an emergency. So I agree with you 100%, but at this point, with the few minutes we have left, I want to transition this back over to the Q&A that we may still have left there. And Carol usually does that. So Carol, I'll welcome her back on the call to do her magic.
All right, thanks so much, Dean. Yes, the first one says, can I integrate your tools into my security stack? For example, Splunk?
Yes, definitely. The Defender for IoT tools have all kinds of integrations, Splunk, QRadar, ServiceNow, many others. So definitely that's a yes. Everyone has a security stack they need to take care of. So yes.
Okay, thanks. The next one says, is there a need for ICS-specific network visibility?
Ariel, do you want to take that one? Or, the answer is obvious. I think that it's yes. I'll let Ariel go in a sec because so passionate about this. I think the answer is yes. Here's the main difference in 10 seconds or less. IT tools look at IT protocols. Control systems have different proprietary protocols, industrial protocols that generally IT systems, they work great on IT, but they don't have dissectors and an understanding behind them for control systems. So I would say, yes, passive visibility would be a fantastic thing that we need to get. And I also wager that if we don't have that today in your control system, you're behind the curve, which means you're more prone possibly to not seeing an attack that may be emerging in your environment as well. But Ariel, what's your thoughts on that? How critical is visibility today specific for control systems?
So if I haven't emphasized visibility enough, then I'll emphasize it more. Visibility is critical for decision making. Visibility means that you understand what all the levels, everything within your perimeter. You understand the systems, you understand if they are working correctly or not, and you have visibility into your attack surface. So ICS control network specific solutions and visibility is critical for understanding that this is not just a system, a mix of IP addresses sending IP messages or Ethernet messages to one another. it runs much deeper. So yes,
I would wager as well that how will you detect things like Colonial Pipeline, those kinds of events in IT or ICS, because ransomware is also increasing and targeting control systems, but how would you detect a scalable type of ransom or malware like Pipedream? And it goes back to visibility plus the people side of looking at what's being visible to understand what the control system is doing normally and what's abnormal about that to spot the adversary. Again, we're dealing with threats in ICS today that have less, there's still some malware involved, but there's less of that and it's harder to detect. And again, it's living off the land.
All right, well, that's all the time we have for today. Thank you so much, Ariel and Dean, for your great presentation, and to Microsoft for sponsoring this webcast, which helps bring this content to the SANS community. To our audience, we greatly appreciate you listening in. For a schedule of all upcoming and archived SANS webcasts, including this one, please visit sans.org/webcasts. Until next time, take care, and we hope to have you back again for the next SANS webcast.